Hey folks, this video is to help you with task A part 3, where you have to set up two equations and solve them simultaneously. Now I've sent you an email, and in that email you've got your question using simultaneous equations with normal distribution, and you've also got this table. It's your percentage points for normal distribution. So you need them two things now. I've gone ahead and set up my solution now then where Sheila's working in this factory. It said that 10% of the components she mix, it takes her more than 90 minutes. So there's my 10% on here, there's my 90, so 10% of the components take more than 90 minutes. And then 20% of the components she mix, she can make them in under 70 minutes. So I've marked on my 10% and my 20% on there. Just roughly marked them on a wee sketch I'll do on there. Now what we need to do is find our z-scores for that. So we've got the variables at 90 and 70. We've got the percentages, which is like your probability at 10% and 20%. We need to get the z-scores now then. So for 10% as a decimal, 0.1. So there's 0.1 there. So your z-score is 1.2816. So my z-score there, 1.2816. And then for 20%, 0.2, there's your 0.2 there, and your z-score 0.8416. 0.8416. Because that's on the left hand side, I'm going to call that z-score negative, only because it's on the left hand side. Now, I'm putting the z-scores on there, but remember you can mark on your standard deviations as well, so that would be like 1 standard deviation away there, maybe 1 there, 2, and then 3. And then on the other side then there would be like 1, 2, 3 over there. So it's just a rough idea of where my 10%, my 20% would be sitting. It doesn't have to be exact, we schedule just do. Now we've got this formula up here now, and that's your standardising formula. So we can use that formula now and introduce all these numbers that we've got going on. If I look at the right hand side first, then my z-score is 1.2816. That's relative to a variable of 90. So 1.2816 is equal to 90. Take away my mean, which we don't know, divided by standard deviation, another variable we don't know. If I look at the left hand side, my z-score is negative 0.8416, and that's equal to the variable there, 70, minus the mean divided by standard deviation as well. Now we're trying to find the mean and we're trying to find the standard deviation, and we're using simultaneous equations. First thing I'm going to do then is rearrange these two equations so that I don't have fractions on them. So let's bring this standard deviation over to the other side, there and there. Now at the minute standard deviation is a divider, we're going to bring it over to the other side, it will turn into a multiplier. So I'll end up now with 1.2816 times standard deviation is equal to 90 minus mu. And for this one I'll have negative 0.8416 times standard deviation is equal to 70 minus mu. So that's my two equations set up. I'm just going to write one above the other now and use my elimination technique. Now we would have done this in semester 2 maths, the access and maths module. So you need to either revise a wee bit of that or follow these steps, just it'll be exactly the same. So my two equations now then, I'm going to write the bigger one at the top. So 1.2816 times standard deviation is equal to 90 minus mu. And my other equation, negative 0.8416 times standard deviation is equal to 70 minus mu. The method for simultaneous equations is called elimination. Elimination means to take away. So I'm going to take away my standard deviations, take away my variables, and then take away my mean. So I need my calculator. I've got 1.2816, take away minus, don't let that get you, 0.8416, double negative, 0 go positive v. So we're going to get 2.1232 standard deviations is equal to 90, take away 70 will give you 20. And then look, if you've got negative mu, take away negative mu, your two takeaways become a plus, so you've got minus mu plus mu. So you have 0, so that's your elimination part done, that's your mean now cancelled out. So all we need to do now then is solve this to get standard deviation. So we'll take this over to the other side, change sides, change signs. If it's multiplying there, it's going to divide over there. Okay, so 20 divided by that gives me an answer now then of 9.4 419, 9.419. I'm going to drop the 9, I'll round that off then to 9.42. Okay, that's my standard deviation. We still have to get the mean. So to get the mean, we're going to do a wee bit of substitution. We're going to have to substitute. Your standard deviation is worth 9.42 into, and you can choose any equation, any of these two equations here. Now I'm going to choose that equation only because I don't need to fight with that negative number there. So under there I have 1.2816 times standard deviation is equal to 90 minus mu. That's going to bring me on now then to 1.2816 times 9.42 is equal to 90 minus mu. Calculator now again, 1.2816 times 9.42, 12.07207. I'll keep the rest of that on the screen, I'll just write them two decimals, is equal to 90 minus mu. I want to get that minus mu now on its own, so I'm going to bring my 90 over to the other side. 90 there's a nice positive number, so I'm going to take it away on the other side. So 12.07, take away my 90, leaves me with negative 77.927. So negative 77.927, I'm going to call it 93. Now you can see there that that's equal to negative mean. I don't want the negative mean, I want a positive mean, but because I've got one negative on each side, I can just multiply through with -1, or just get rid of them two negatives. There we go, happy days. So we've got Sheila's mean now. Takes her 77.93 minutes to make one of these components, and then we also know that her standard deviation was 9.42, so if we add that on, 9.42, 9.42, 9.42, and so on. But that's the two answers you're looking for, your mean and your standard deviation. Alright.